Okay, some of this problem is from a while ago, but there's a part in this because there's some kinetics on here and all kinds of fun stuff. Part of this problem, though, is recent, so we're just going to get all it. So here's the thing. It says, okay, let me grab a pen. Here's your equation. The whole problem is about this equation where you have methane gas and 2 moles of chlorine gas, and then you make this stuff called, what is this called? Dichloromethane, and then hydrogen chloride gas. And the first question is, if you have 25 grams of this and 2.58 moles of this, what is the limiting reactant? And the easiest way to do that problem is to pick a product. I always pick the first product because I'm a creature of habit. I'm going to do this stoic problem first, this stoic problem second, and the answer is not the biggest answer. The answer is the smallest answer. So having said that, now on this first stoic problem, because this is a G, I have to calculate the molar mass of methane, which is 16.04 grams per mole. This is a mole, so remember the mole is the most important concept in all of chemistry. You only have to calculate the molar mass if you're in grams and you need to get to moles. If you're already in moles, you don't need to calculate. And I'm just going to stop at moles because there's no reason to go all the way to grams. You just have to do this. Okay, so problem one is the problem that starts with methane. So remember, the first set of parentheses is the given, 25 grams of CH4. And then remember you do the U, so step one, step two. I know that there are 16.04 grams of chlorine in 1 mole of chlorine. Now I'm in moles, and now I'm going to use the mole ratio. And so I can see up here that there's a 2 to 1 mole ratio. So the balanced, I'm doing this one. Between methane and dichloromethane, it's a 1 to 1. So the balanced equation shows me that for every, oh, here's my problem. I'm an idiot. This is CH4 and this is CH4. I'm still working this first problem. Let me switch colors so I don't screw up. I'm working this problem first. Step one, step two, it's a 1 to 1 mole ratio. So for every 1 mole, let me go back to blue. For every 1 mole of CH4, you will make 1 mole of CH2, Cl2, which is dichloromethane. This cancels this. Grams of chlorine or methane cancels grams of methane. When I put this in my calculator, I have enough methane to make 1.54 moles of CH2Cl2. Now, my second problem, let's go to purple. Now I'm going to do this problem. Okay, it's a totally different problem because here's the thing, if you remember from last year with limiting reactants, um, what you do is you do 2 problems in one. If they give you in for 2 givens, it's 2 problems because each problem can only have 1 given. And then the answer is the smallest. So then if I do this problem, the given is 2.58 moles of chlorine. The most important concept in all of chemistry is the mole, so I don't have to calculate the molar mass of chlorine because I'm already in mass, unlike what I had to do up here. The balanced equation shows me that for every 2 moles of chlorine, you will get 1 mole of dichloromethane. This cancels this. 2.58 divided by 2 is 1.29 moles. Now, I just want to go through this and I need you to understand what I'm telling you here. We have enough methane to make 1.54 moles of dichloromethane. We have enough chlorine to make 1.29 moles of dichloromethane. That means the answer to the problem, how much of CH2Cl2 could you make? It's 1.29. Because this is the smallest answer, chlorine is the limiting reactant. It limits the reaction because when it runs out, the reaction stops. And if this is the limiting reactant, then methane is the excess reactant, because when this reaction is done, all of the chlorine will be consumed, but some of this stuff will still be floating around. Okay, so that's the first answer. What's the limiting reactant? I guess it says what's the limiting reactant if I go up here. Identify the limiting reactant when the methane and the chlorine gases are combined. Justify your answer with the calculation. That should take care of it. 2, calculate the total number of moles of CH2Cl2 gas in the container when the limiting reaction has been totally consumed. We actually have already done that, because I always go to the first product. The answer is 1.29 moles. You will make 1.29 moles of CH2Cl2, and then C calculation in AI. All right, next thing. Initiating most reactions involving chlorine gas involves breaking the chlorine-chlorine bond. This has a bond energy of 242 kilojoules per mole. Calculate the amount of energy in joules necessary to break a single chlorine bond. Now here's the deal. Here's chlorine, here's chlorine. This is a pure covalent bond. And the question is, how much energy, this is the stuff you couldn't do till recently, it takes 242 kilojoules per mole. That means 242 kilojoules total to break 1 mole of these bonds. And so the question is, I don't want to break a 1 mole, I want to break a single mole. So here's your calculation, 242 kilojoules per 1 mole of bonds. I'm just putting the bonds in there, you don't have to. From last year, you know that 1 mole of anything can, including bonds, 1 mole of bonds means you are breaking 6.022 times 10 to the 23rd bonds. And so a mole of bonds cancels mole of bonds. So now I'm in kilojoules per each bond. And then if you read the words up here, it says calculate the amount of energy in joules. So then I have to realize that right now I'm in kilojoules. 1 kilojoule is 1,000 joules. And if I do 242 times 1,000 divided by 6.022 and round to 3 sig figs, my calculator says 4.02 times 10 to the negative 19 joules. Okay, now on here, calculate the longest wavelength of light that can supply the energy per photon necessary to break the bond. Now this is crazy. So what we're going to do is, here are the 2 equations on your formula sheet. E equals h nu and C equals lambda nu, and you have not done this for a long time. We will definitely review this. But the question is, now remember, E means energy, and energy is measured in joules, and so we know that number because that's what we just calculated. C is, sorry, let's just go in order. E is energy. H is a constant called Planck's constant. It's named after Max Planck. I don't even know what that is, but it's on your formula sheet. You look it up. C is the speed of light. That's a constant. I don't know what it is. Look it up. Okay, I lie. I do know what it is. And then lambda is what we're looking for, because that's wavelength. And the problem says calculate the wavelength. Now, what makes this problem particularly difficult is you have to do a lot of algebra, because we're looking for wavelength. So the first thing, let's take this equation right here and solve for wavelength. Wavelength would be C over nu, right? Because to get wavelength alone, you divide by C. But then if I go up to this equation, but nu is equal to E over H. So now I come down here, so lambda is equal to C over E over H, which you can't have, so we don't do this. So remember, you leave the top alone, and you, instead of dividing, you multiply by the reciprocal, so H over E. So that is a fancy way, let me start a new page, of telling you, you have to do a lot of algebra to figure out that the wavelength is going to be equal to H times C over E. Okay, what is H? It's Planck's constant. It's 6.26, something like that. Hang on, I gotta look it up. It is 6.63 times 10 to the negative 34 joules times second. That's what H is. C is the speed of light. It's 2.998 times 10 to the 8th meters per second. So do this. And then E is the answer that we just got, but it's downstairs, so we're going to multiply by the reciprocal. And the answer we just got was 4.02 times 10 to the negative 19th joules. Now watch what happens. Joules cancels with joules. Seconds cancels with seconds. They asked you for the wavelength in meters. So if you put 6.6, so if you type in 6.63 E negative 34 times 2.998 E8 divided by 4.02 E negative 19, your calculator will say 4.94 times 10 to the negative 7th meters. And that's wavelength, and that's a tough problem. Again, let me just run through that algebra one more time. This is what we know. We know that E is equal to h nu, and we know that C is equal to lambda nu, and what connects these two equations is that this is the same nu. So another way to do this is E equals h, but instead of nu, you sub in C over lambda, because if you take this equation and solve it for lambda, it would be C over nu. And so now if I took cross products, H times C equals E times lambda. And so if you're solving for lambda, you would divide both sides by E. However you do it, that's the equation you use to solve the problem. Okay, 7. This is a long time ago. The following mechanism has been proposed for the reaction of methane gas with chlorine gas. All species are in the gas phase. All right, so here we go. First step. First question, is CH3Cl a catalyst or is an intermediate? Justify your answer. First of all, I got to figure out what the overall equation is. So you cancel things that are on the top and the bottom. And by the way, we already know the overall equation because way back in the beginning, it's right here. It's the same problem. We know what the overall equation is, but let's see if we can get it. So CH3Cl cancels there. 2 Cl's, and then 1, 2 Cl's. And then, I got another Cl here and another Cl here. And then I have a CH3 here and a CH3 here. And when I'm all done, it looks like this H is supposed to cancel. Did I make a mistake here? Okay, let me go back and erase this. I'm going to pause this for a minute because there's something wrong with this. Hang on. Okay, I'm ready to start again. All right, I made a typo, and this is the first time I've seen it, and I don't feel like retyping this, so let me show you why I made a typo. If you look at step 4, 1 carbon, 3 hydrogen, 2 hydrogen, 2 Cl, 2 Cl. This isn't balanced. There is an H here, which has to be there. Otherwise, let me go to blue. I got 1 Cl, 2 Cl, 3 Cl on the left, 2 Cl, 3 Cl on the right. All of these are going to cancel. And then I have CH3 on the left and CH3 on the right. And this cancels this, and this H cancels this H, which is very important because what happens is, if you look, I'm going to switch to purple. I got Cl2 plus Cl2, and I have a CH4. So I have CH4 plus 2 Cl2s. Now let's go back to the very beginning. That's what we're expecting, CH4 and 2 Cl2s. And then on the right, it looks like we have CH2 Cl2 plus 2 HCl, one here and one here. And so that's it. Now the first question is CH3 a catalyst or an intermediate? Okay, first of all, it's either a catalyst or an intermediate because if you look, CH4 and Cl2 are reactants. CH2Cl2 and HCl are products. So these are the reactants, these are the products. Anything crossed off is either an intermediate or a catalyst. And the reason why it's an intermediate is that intermediates aren't there in the beginning and catalysts are. So if you notice at the left-hand side of step 1, it's not there. What the AP board will say, intermediate means middle. And so if I'm going to go up here and just erase this very quickly now that I've shown you how to do that. So I'm trying to erase it relatively quickly. Now remember, Mrs. High made a mistake, so I need to fix this for next year for Higgins. I'm going to grab black. There has to be an H here because there's 3 H's here. No, there's 3 H's here and only 2 here, and so there's an H here. But the interesting thing is what the APO board is, the intermediate, because it shows up, okay, it shows up for the first time. It shows up in step 3. And then it's used up in step 4, and that's what happened on the intermediate. It shows up in the middle. It gets in one step, it gets reconsumed in another step. It's not there in the beginning. It's not there at the end. So that's an intermediate. Okay, this is my favorite question. I'm going to come back to this. But notice, remember that the rate law comes from the stoichiometry of the slow step. So on this problem, it'll say identify the order. So here's the thing. If you look back, the slow step is, I got to go back to, sorry, this slide. The slow step is CH4 plus Cl. So looking at the slow step, you would say that the rate law is rate is equal to K times the concentration of CH4 to the first power times the concentration of chlorine to the first power. Because if you look at the slow step, the stoichiometry is 1 to 1. Now here's the problem. See, the only things that can appear in a rate law are the reactants. And Cl is not a reactant. So now I have to go back to step 1. So one of the things is if the slow step is step 2, you have to back sum. Well, step 1 says that Cl2, 1/2 of Cl2, no, it doesn't say that. It actually says, well, let me look instead of trying to, Cl2 equals 2Cl. Now that you understand bonding, maybe this will make more sense. Cl2 becomes 2Cl. Basically, what we're saying is if you have a bunch of chlorine molecules that are bound together with covalent bonds, remember the reason why they do that is then they can both have 8 electrons in their valence shell, and you snap this bond, for every 1 molecule of Cl2 you bond, you're going to end up with 2 atoms. 1 Cl2 molecule makes 2 atoms. Or another way of doing this is if you solve this for Cl, because we got to get Cl out of here, 1/2 of Cl2 is Cl. So you're going to get twice as many Cl atoms, or you could say you're going to get half as many Cl molecules. So now I'm going to come up here And everywhere there's a Cl, I'm going to substitute 1/2 of Cl2. But then you can see that this would change to Cl2, but now the stoichiometry would be 1/2. And so the question is, what is the order of the reaction with respect to CH4? It's first order, because this is a 1, but with respect to Cl2, it's a 1/2 order, because the exponent is a 1/2. Okay, I hope that helps.